Hello dear students, my name is Vishal Arun Naik. I am working as an assistant professor in Department of Chemistry. So our today's video's topic, applications of this flame emission spectrometer and the limitations of this flame emission spectrometer. So there are two types of applications are there. First is qualitative application and second is quantitative application. So in a qualitative application, that is also called the identification of element. So the metal ions which are present in a different form of a sample or different samples get determined by using FES. So which are those samples? So sodium, potassium, calcium, magnesium present in the soil are also determined by using this flame emission spectrophotometer. Then fertilizers, we know that fertilizers contain NPK, that is potassium, sodium, calcium, magnesium, different types of metal ions present in a fertilizer also determined by using flame emission spectrometer. Then biological fluid contain different type of elements are also determined. Biological fluid means blood samples, urine samples and other samples are contain different type of metals which can be determined by using flame emission spectrometer. Then lead, if lead present in a petrol or cement containing calcium, magnesium. So in cement industries, petrol industries, oil industries, we use flame emission spectrometer for determination of the metal ions. Then glass analysis, that is the purity of glass, also determined by using this one. And then organic compounds, boron, physiological and clinical studies, we use flame emission spectrometer post-oxide. So there are wide applications for the identification of metal ion of this FES. The next application, that is the quantitative analysis. So particularly this instrument gives the not just in a quality, we also determine the quantity of the sample or the metal ion present in the sample. Okay, so there are three different methods which we use to determine the quantity of the sample. So first is a calibration curve method. So this is in a graph. So what is the calibration curve method? So we have to prepare a series of standard solution and one by one we aspirated that series of sample solution into an flame and determine the emission intensity of particular substance. So as we know, the standard solution means whose concentration is known. Okay, suppose I have to determine that is the copper. Okay, so we have to prepare a standard solution of copper. Okay, then after aspirating sample solutions, burn our sample solution which is in metal ions which present in that sample solution, we have to determine, so which is aspirated in a flame emission spectrometer. After aspirated into that, we get emission intensity, and by using that emission intensity, so by using a standard solutions, we prepare this graph, and then our sample contain particular amount of emission intensity. So by using that emission intensity and by using this graph, we determine what is the concentration of unknown solution is there. So this is a very simple method which is used in the instrument or which is used in the software of that instrument. So this is the widely used that is method for the quantitative analysis of any kind. That is in AS also we use this method. So this is the calibration curve method. Then next method, that is the standard addition method. So in this method, emission intensity of unknown solution is found by aspirating into a flame. Then a series of standard solution in which that is the unknown amount, unknown x remain constant. So as we seen in this graph, x, the amount of x is remain same. That is our unknown sample solution. And the standard solution, that is we are preparing, we add that standard solution in a different amount. In the first one, we not adding some standard solution, that is a 0 amount. Suppose in second one, we add 1 ml. In third one, that is 2, 3, 4 and 5. So the unknown sample solution, the quantity is remains same, x remains same, but the quantity of standard is varying. Okay, so one by one we aspirated that all the samples in a flame emission spectrometer. Then we plot this graph against emission intensity and concentration of standard and concentration of unknown. We get this type of a graph, and if we extra plot that graph on another side, on this side, we get our concentration of our unknown sample solution. So this is called a standard addition method because varying amount we add standard solution to that. And the last method of quantitative analysis, that is the internal standard method. Okay, a series also in this method also a series of standard solution containing the same element is present we have to prepare that. Then the fixed amount of a suitable internal standard. It is same as the standard addition method, but internal standard is quite purified as compared to standard solution. So internal standard solution is then added into each of standard solutions, then blank, and then sample solution. So all samples which are we prepared, standard solution, blank, and our sample solution, we have to add an internal solution, internal standard solution into that. Then one by one we aspirated that into a flame, and we determine or we get emission intensities. Okay, so we get emission intensity of the analyte and the emission intensity of the internal standard. So by taking the ratio of that one and we plot against the standard solution which we prepared, okay, and by using that we also get the concentration of unknown solution. So these are the three general methods to determine the quantity present in the sample solution, okay. And the last point of our today's video, that is the limitations of flame emission spectrometer. Any instrument has its own limitation, okay. So flame emission has some quite limitations. So first limitation, that is gives the total metal content in the sample but does not give any information about the molecular condition of the metal. It actually gives which metal ion is present in our sample solution, but what is the condition of that metal, whether that is oxide, whether that is sulfide, chloride, or any other. It does not give any information regarding the molecular condition of the metal. Then it cannot be used for the detection of all metals. Only group 1 and group 2 are roughly detected. Okay. Then only liquid sample get introduced into a flame emission spectrometer. We cannot analyze the gaseous sample and solid samples directly into flame emission. Only liquid samples are determined. And the most important limitation is that interference by the same element or interference by the element with the same wavelength. If two elements have the same wavelength, okay, so determination will be wrong, or the quantitative analysis becomes wrong, because if two elements are present, it becomes analyzed as only a single element. Okay, so the magnesium and iron, if we have to determine the magnesium and iron, okay. So if magnesium is present, it detected as an ion, okay, and if we have to determine the iron and magnesium is present, so it determined as a single. So this is the interference which is produced in a flame emission spectrometer. And the last limitation, that is the elements with low ionization potential not estimated correctly. Today we actually discussed the instrumentation part and the types of burners in flame emission spectrometer. Then applications of flame emission spectrometer, generally applications are quantitative and qualitative, okay, and the limitations of flame emission spectrometer. So we stop our today's video. Thank you so much.